Olive.
We still have a space today, man.
Yeah.
Yeah, awesome. So we have data science. We'll think data science. We'll dream data science. It's data science, man.
It's gonna be a good Sunday.
Yeah.
Okay, I think I put it. Okay, perfect. Good. So we shall start. I have here the blank script to
what's this? Machine learning. Okay.
Develop the solution. So we are going to learn about machine learning and linear regression. Okay. We will start with this data set that every row is a state from the United States. And these two columns are the alcohol, if the car was in, how many cars were involved in alcohol. I can see it here better. So it was percentage of drivers involved in fatal collisions who were alcohol impaired. And the total, the accidents, is the number of accidents per billion people, I think. So we have this scatter plot representing on the x-axis the alcohol and the accidents. Then we will learn what is machine learning. That's a mathematical equation that we need to calculate. And this is not the best one. So after we know what we want, we will ask Python how to calculate the linear regression model here. And then once we calculate the linear regression model, we make a prediction. Then we visualize the predictions versus the real data. And lately, we are going to compare with other models, like the random forest and super vector machine. And I will show you that you don't even need to know the maths behind the code to make the mathematical equation of the random forest or the super vector machine or any other. Good. So give me 1 second. I'm gonna put the solution on the other side so that I don't miss the point. Give me 1 second. Good. Okay, so I'm gonna start with Aria. Aria, which is the name that you have in your computer? Aria or Aria Akare?
Aria.
Okay, perfect. So I'm giving you the remote control, okay?
Okay.
Perfect. So, do you know what machine learning means, Aria?
Your voice is cutting.
Sorry?
Yeah, it was a glitch, I think. Your voice was not coming.
Okay. Now it's good?
Yeah, now it's good.
Okay. So machine learning, what does it mean? That the machine learns. Okay, so what does it learn, the machine? A mathematical equation. You see this, Elvis?
Yeah.
Have you ever seen a mathematical equation, Elvis?
Yes, I see it. Yeah.
Give me one example of a mathematical equation. Elvis.
Mathematical equation. I'm not good in math, but I know linear algebra, then cosine.
For example, y equals 2 plus 3 multiplied.
Okay, y equals 2 plus, yeah, true.
That's it. So the moment that you substitute two numbers here in A and V, you get this line here, okay?
Yeah.
So you can see that, for example, if the alcohol is 1, how much is the total accidents? Is 1 multiplying 2.8 plus 2.7. And this gives us 4.5 here. Okay.
Yeah.
If Elvis, we calculate every single line, we get every single coordinate for this equation, we get this line. Okay. Like the definition of a figure in maths is the points x, y that fulfills the mathematical equation, you know? And for example, you have a mathematical equations that represents cool graphs. For example, cool math equations, figures. For example, to represent this Batman symbol, you have this mathematical equation.
Okay.
And I don't know if there is anything else cool here. Yeah, this is for a heart. This is for kind of butterfly, happy face. So in the end, a mathematical equation is the points in which they fulfill the condition. Okay. So here, if we say that this is the mathematical equation, we can say, okay, it's good. But then if we put the real points contrasting the mathematical equation, what do you think, Elvis?
What did you say?
When we put these points in the graph with the line,
okay,
what do you think? Is this line a good mathematical equation for these points?
Let me look at it again. When we put the when we put the graph in the line, okay. Well, it's cool to me, man.
So the white line represents this mathematical equation.
Oh, okay.
When you put the dots here, do you see that the line is not as good to represent the average trend of the points?
Yeah.
Like I think, Aria, you are more related to these topics,
Yeah.
right?
Yeah.
Good. That's why I'm gonna be asking to the person who knows the less, so that we can understand everything. But then later, when we go with the code, I will ask you for sure. So Elvis, do you get this? Do you get the sense here?
Yeah.
Good. Then what do you think we can change in the mathematical equation so that the line is nearer to the trend of the points?
For this network. Oh, my network. Okay, let me close this door.
This
closed.
You see here, as we change the numbers in the mathematical equation, the line is changing the position, right?
Yeah.
So what do you think the machine needs to learn?
It's learning the accidents and the alcohol, like the equation, right?
That's it. You know, in the end, machine learning means that the machine learns the mathematical equation that represents the trends of the data, the patterns.
This X and Y axis with the line, it represents the trends of the data.
Yeah.
Okay, awesome. Got it.
And we will see, for example, different models. If you see here, in the end, we have, do you see that we have 3 figures, 3 models: linear regression, random forest, and support vector machine? Can you see that they are like a shape of an equation?
Yeah.
So then you later need to think which one is the best model here. But in the end, that is it. Machine learning, the machine learns a mathematical equation. That's all. Nothing, no more. Good. So I'm gonna put this here. That's clear, right? That all that we need to calculate is a mathematical equation. Okay. So how is the algorithm of the linear regression operating? So if we check this video, let me check 1 second. Okay. So we have understood that we have a set of points, and then we have a mathematical equation, and the line is moving as we move the mathematical equation. So we need to find the line that captures the trend of these points. How can we measure if this line is the best for the points, Elvis? For example, for these 2 points. What would you think? Like, it's more simple than you think. So for example, if you have this point,
okay,
and the line is in this point for the 5, how is the line failing to capture this point? This amount, right?
yeah.
That's called the error. But do you need to calculate just this error or all of the errors?
I think.
What do you believe? What do you believe? Like,
I think
it can be
okay.
mistaken.
I think this calculate this error.
Just this error?
But what if the? I think because you can't. I think you can't calculate just this error because it might spill over. I'm using my own thinking. Because if you calculate only this error, what if I say you calculate all the error?
That's it. Because in the end, the line needs to be capturing all the points.
All the points, yes.
You know, on average.
Yeah.
So you would calculate the error for every point.
Yes.
And then once you calculate the error for every point, what would you do to measure the total error of the points to the line? You would sum all of the errors, right?
Yeah.
But if you sum the errors, it may give you 0.
Yes.
So what do you do then? You square the errors. So the moment you square the errors, you see that when you square is side by side.
Yeah.
So you get the area of a square. That's why it's commonly used the term squared errors.
Okay.
Have you studied this before, Arya?
Yeah, I've studied it.
The squared errors. Okay.
Yeah,
So
am I
then,
audible? Yeah.
sorry?
Yeah.
I think basically what I've studied here is I took some classes in statistics. So the only thing I know I square, I've not gone deeper into vector and linear regression. I just stopped at squaring standard deviation and knowing the
variance.
away from
the concept of the variance is kind of this.
It's kind of this. Okay, so I can be able to relate now.
In the end, in statistics, is everything related to this topic because you are all the time measuring the error. Like you get a mathematical equation and you need to compare how these predictions of the mathematical equation compare to the reality, because machine learning is not a perfect science, you know? Like every time that you increase one unit to the right, you don't always increase 2 units to the up. We will see that later. Okay, so here you see that we have the sum of square errors, right, Elvis? How much is it now?
17.04.
Okay, so if you put a graph to the right, measuring on the y-axis the sum of square errors, and on the x-axis you are moving this coefficient from the equation. This here, you see that we are moving this one, right?
Yes.
So what is happening when you move that number? You see that the errors are increasing or decreasing?
Yeah, increasing and decreasing, yeah.
So do you see this curve that we have to the right?
Yeah, I can see it. Then
how can we calculate the best possible number in the mathematical equation? Because now the number in the mathematical equation, how much is it? Minus 0.44, right?
Yeah, minus 0.44, yeah.
And we would like to have the number that is here, right?
Yeah.
Why? because it would give us
It
the lower
the
error.
least error.
That's it. Do you get this concept, Elvis?
Yeah. Huh? Can you hear me?
Yeah. Do you get this concept of
I get.
getting the least squared error?
Well, I'm getting it a little. A little. Yeah. Yeah.
Okay. So how do you get there? Have you studied derivatives,
Derivative.
Elvis?
Derivatives. I'm not going to. I just stopped. I stopped at statistics, and I'm not gone deep into machine learning. It's just basics of exploratory data analysis. Yeah.
Do you remind from a school that at some point that if they taught you derivatives, maybe in math?
They taught us derivatives at that point, but at that point when we were younger, we never understood math.
Yeah.
So my, well,
And don't you remember that you used derivatives to minimize and maximize results?
oh yeah, we did.
So here we need to apply the derivative to minimize the squared error.
Okay.
And get the best number here that produces the least square error.
Okay.
So how do we get there? With the derivatives, because it's giving us the tangent slope. And the tangent slope here is 0. So in the end, what would you do here is you need to calculate this number. So you apply the derivative equal to 0, and you just substitute and get the best possible number. And that's how you get the best number of the mathematical equation.
Okay.
Have you get this idea, Arya?
Yeah.
You don't
First
have
you
any
took the
doubt?
derivative. Yeah, no.
Okay, good. Because this is the most simplest model. Then, if we see this concept in deep learning, we will see that it's kind of similar, just it's different in one thing. So, for example, I don't know if I can stream this here. I will check it later. So here we have the numbers of a mathematical equation. You see?
Yeah.
Yeah.
The thing is that a neural network we may think that is very complicated because it has many parameters. But do you see that this is also a mathematical equation like we saw in the linear regression, Elvis?
Yeah, the same.
Yeah.
But it looks different, the lines.
Yeah, but the lines doesn't have anything to do with the previous representation, just the mathematical equation.
Yeah, it's the same, yeah.
So in the end, what the machine needs to learn is the weights on the W1, W2, W3, W4, etc.
Yeah.
So then you think, okay, how do you do that? So okay. In the linear regression, you would just compute the cost, that is the sum of square errors. You equal it to 0, make the derivative, and you get the minimum error and the mathematical equation. How do you do that in the neural network? Because for the neural network, isn't possible. You have a lot of local minimum. Do you see this, Arya?
Yeah, I'm seeing it.
And do you have any doubt so far?
No, none.
Okay. Like, have you studied that when you have a lot of minimum, you cannot apply the derivative equal to 0, right?
Yeah, here we cannot apply that because we have many minimas here.
Yeah. So how then do you think that the machine will learn the equation here?
I think it will first have to iterate over some values, I think.
That's
Go
it.
forward or backward. Yeah.
So you start at some random point, and then here you calculate the slope of the tangent, And then you say, okay, as the tangent is going up, I think I may need to go to the left. And here, as the tangent is going down, I need to go to the right. And that's how, after many iterations, you get to learn the best possible number for the W in the mathematical equation. So that is the difference.
I have one question.
You go.
Now, how does it know that it is the global or local minima?
Okay.
How does it know?
Because in the end, what it does is starting the errors in several points.
Okay.
Good. But the point that I want to make here is that you have the most simple model, which is a linear regression, and one of the most complex model, which is a neural network, right? And in the end, they are both the same. They are learning the weights in a mathematical equation, right, Elvis?
Yeah.
That is it. I mean, that's the mystery of machine learning. The machine learns a mathematical equation. That is it. Sometimes it does it with one algorithm that iterates. Other times does it with a derivative equal to 0 in the case of the linear regression. But it's all the time the same.
I have one more question.
You go.
You use the term weights. What does weights mean?
The base?
Yeah.
What do you mean in the base?
Weights. WEIGHT. Weights.
The weights.
Yeah.
Okay. The weights is the another number for the parameter here, A and V as well.
Okay.
They are also
so
like
just the arbitrary
coefficients.
values. Yeah.
Yeah, coefficients of the mathematical equation. There are many numbers. Like normally it's a pity because you have got many concepts for the same, many words for the same concept, like a lot of synonyms. But every time you have these questions, ask it to me because they are really good for you to understand everything. I'm pretty sure people who will watch this video later probably will have the same doubt. So, a practical example: how is machine learning applied in real life? So here, Tesla is taking the numbers from the pixels in every image that captures. It puts these numbers into a mathematical equation to predict the objects, the distance, and based on these predictions, the car takes an action or another.
Yeah, true, yeah.
That's everything.
Yeah.
And this is applied to, I mean, if you have a record of historical data, you can calculate a mathematical equation to predict the future. Because, for example, Elvis, when you were working, what was the variable you wanted to predict? Like the duration time, maybe?
Yeah, I want to check. Oh, yeah, I was about to predict. I was predicting through the trend and how the company will actually, we're based on historical data. I was predicting that we won't make sales. Yeah, that was just it.
Yeah, also that, like you can predict the sales based on historical data.
Historical data, yeah, I was predicting.
And you do that with a mathematical equation. That is it. The thing is that depending on the problem, you need to apply different mathematical equations.
And, it's Excel and Power BI makes it easy for you, man. Just like this is machine learning, man. So
you will see later. But like machine learning is not perfect. For example, here you can see that the machine learning model in the Tesla is confusing the moon with a semaphore in amber, and it's making the car to slow down. You see?
Okay, due to context.
Yeah. So it's not a perfect science, but it's giving us a lot of powerful tools to automate things like the car, for example. And the future is going to be a lot like that. Okay, so here we have these points from the alcohol and the accidents. If we would like to make a line here, do you think this is the best line, Arya?
Can you repeat the question?
Do you think this is the best line to...
No, it is not covering all the points.
That is it. So that is the question. How do we calculate in Python that line? You can control the computer now, I think, but I think that I have it here.
Can you see my cursor?
Sorry?
Can you see my cursor?
No. Can you click?
No.
You need to click on my computer to have the control.
I'm not able to. I'm clicking.
Okay. Try again. Okay.
Wait a minute.
Now it is. Good. Okay, so you told me you haven't programmed ever, right?
Yeah, I'm complete beginner.
Okay, perfect. So you already know what we need, right?
Yeah, we need to cover all those points.
That's it. We need to calculate the mathematical equation that captures the trend of the points, right?
Yeah, yeah.
Are you familiar with the concepts of programming? For example, what is an instance, what is a function, what is a library, etc.?
And no, I'm not quite. I'm a beginner, so I'm not able to code. I just know what the function is and how do you define it.
Good.
And for library, we have to import library and then you have to use it, something like that. But I've never actually used it or coded it.
Perfect.
For me, I think basically I've tried like scikit-learn and Terras. Have not just used those libraries because I feel like I'm not ready yet.
Yeah, and I don't want to teach you in a way that you need to know concepts. I want you to teach you in a way that you know discipline, how to look for solutions in Google, etc.
Okay.
So
yeah, that's what I want to learn.
Here, as you don't know the elements of programming, what do you think is the most important element? For example, I'm gonna import here a library. Okay, I'm gonna import Plotly Express as PX, and I just put the library here. Do you see that the program has done anything like wonderful? No, right? It just gives me here a direction in my computer. Okay. So now I put an instance. For example, let's say that we are writing down the grades of math, like a 4, an 8, and 6. Average. So here we have grades, and it's an instance. You see that here it gives you an instance. Then if I want to make a bar plot, I use bar, and this is a function, right?
Yeah.
And you see that after I put the function, I put a parenthesis. This is all the time happening the same way. When you have a function and you want to call it to be executed, you need to put the parenthesis. So now, what is it asking? Data frame, X, Y, color, etc. So you would use the X to put grades, and it produces this graph. Okay. So which of the three elements was more important? The instance, the function, or the library?
I think the function.
Yes. So from now on, every time that you want to solve a problem, you should be thinking, what is the function that takes me this object and convert it into this other object that I need? Okay. In our case, we want to have this data frame, pass it to a function, and the function will return the mathematical equation. Okay?
Yes.
Okay, so now, if you're a beginner, how would you look for this in Google? You need to
Yeah. So
compute the
yeah,
mathematical equation of a linear regression.
I have to compute
Yeah. So how would you ask in Google?
that what is the mathematical equation of the function.
So when you're in Google, you just search by the keywords. So linear regression,
Yeah.
Python. That is it. And now you can control the screen. Where would you
Yeah.
go?
The first link, this
Into
one.
which? Okay, you may go there. And let me know the thinking process you have while you navigate.
Yeah. I think it is loading.
Okay. Okay. Now. So you see this, right?
Yeah.
And you have a lot of words here, a lot of statements. What would you put the focus on? You know that you need a function, right?
Yeah. A function.
And how do you identify the function in the code?
It is in the parenthesis in the
That's it.
arguments. Yeah.
All the time. You need to look for the parentheses. And do you see here
Yeah.
some parentheses? I mean,
No.
there is here, but it's not related to code. So
No. So I'll
navigate
scroll down. Yeah.
until you see some parentheses. Okay. So how many
Yeah.
parentheses do we have here? This is the first
Two.
one, right?
Yeah.
This is another one.
And this
These
is
are
another.
another ones. These are another
Yeah.
ones. This is another one. So
Yeah.
now you would need to select the candidates for your linear regression function. Which of these do you think it's the function that calculates the mathematical equation?
And the fourth line, y is equals to this thing, I think defines it. And then we use reg equals to linear regression to call the function, I guess.
Okay. That's right, like reading this all in once. But let's say that you are putting the focus on the function, just the function that calculates the mathematical equation. Which one is
Okay,
it?
so the linear regression one.
Okay. So you would select this line and you would copy
Yes.
paste it, right?
Yes.
Okay. And it's giving you this error. Do you know
Yeah,
why?
it is saying linear regression is not defined.
And do you understand these errors?
No,
And you, Elvis?
I think
Linear regression is not defined.
Why,
Okay.
why is this?
because we have previously not defined linear regression as a function.
That's it. Like if you would have used here hello, we get the same error. Name linear regression is not defined. Name hello is not defined. So how should we define linear regression? Can you see it in the code here?
Yeah, from it imported the linear regression from
You
scikit-learn
select.
linear model.
You select the line. That we
From
need
the
to copy.
second line, this line.
Okay. Everything, right?
Yeah, second line.
Okay. So you come here, you paste it, and now you don't get any error, right? And if you put linear regression, it recognizes.
Yeah.
Good. So if we copy paste this, will it give us an error?
No, no, I think not now. Okay, so we have not defined x.
That's it. This is another error. But at least we have gotten to the linear regression, right?
True. Yeah.
Yes.
Okay. So what should X be? Elvis?
Huh?
What should X be here?
X. Okay. Let me see. X, Y. Well, X, not too sure.
Could you, Elvis, tell Aria the trick that I implement all the time to search the documentation of the functions?
The trick, okay. First, you're supposed to go to Google.
That's to look for the function. But once you have got the function here, you can access the documentation on how to use this function.
Tab.
You go. Control the computer. Elvis.
Okay.
You need to click.
Okay, I'm clicking.
Okay, good.
Right there. Okay.
The tab is to suggest what to put, but not to get the information on how to use the function. That is it.
Yeah.
So,
tab.
How do you interpret this, Aria?
X is something like a matrix or array, and Y is also a similar kind of parameter.
That is it. So what should X be in our problem? That we are trying to fit a line, this line. I'm gonna move it here. And in the X axis, which variable are we using?
Alcohol.
And in the Y, accidents.
Accidents.
That's because we want to use the alcohol to predict the accidents, right?
Yeah.
So which one is the X?
Alcohol.
That's it, because it's the variable that we want to use to explain the target, which is the Y, the accidents, right? So, Aria, how would you put here the alcohol and the accidents? You go with your gut.
So we have a list of alcohols, I think, data points, or what do you call? What is AL, AK, and AZ? I didn't get that abbreviation.
This one?
No, the abbreviations AL, AK in the data frame.
The DF, you mean? Sorry.
Yeah. So we'll just select the alcohol column.
Okay.
I think.
Yeah. You go. Control the computer and you try to substitute the X or to define the X.
Wait a minute.
You can try.
It is not working. My mouse is not working.
I need to give you the control to. Now, can you try? Yeah, good.
Yeah, now I can, I think. So first I'll write X.
Okay. Let's do it on another line. I will show you. Here in the Jupyter notebook, you need to be working with the cells, right? So to create a new cell below, you press V. Of Barcelona.
Okay, V.
Yeah, and now to edit, you go with Enter.
Okay.
Go with Enter.
So, yeah, I'm there.
Oops. Enter.
What happened?
Here. Okay, good.
Okay, so X is equals to some that values that we have in the alcohol column.
Yeah.
How do I put it? As a list? Or
so try with your intuition. Like, would you be putting this like 5.64, etc.?
Yeah, but it will take a long time. Yeah.
Okay, but this is very inefficient because we already have that information in this variable, right? In the F.
Yeah.
Like if we use here df, how can we tell Python to just select this column, alcohol?
Okay, so df and we'll pass the argument or of alcohol, I think.
Okay, so the question is, what is df? Would you know, Elvis?
Data frame.
Okay, and the data frame is a type of?
Huh?
The data frame is a type of library, function?
Yeah, it's from pandas library.
But
right?
pandas is the library, but the data frame is a type of object.
Okay.
Okay, do you know this concept, Arya? The object?
No. Yeah. I know. No.
So the
I'm not sure.
object contains a data structure. Okay, an object may be, for example, this. And then if you want to access the object, you, for example, the 4, you need to pass a brackets 1, because Python starts counting from 0.
0 indexing, yeah.
That's it. So like you see, a here is an instance, right? Which is like another synonym of object, kind of.
Okay, so we'll now use data frame and pass alcohol.
That's it. You go.
Okay. It is not clicking. Yeah, now it is. df and list, I think. Yeah. Alcohol.
Yeah, you go. And now you execute.
Using
to execute this, shift enter.
Shift enter.
Okay. What is
So
the
it
error?
is not
Do you understand this
alcohol
error?
name error. Yeah, name error. Yeah.
So we see that alcohol is here, but it's telling us that alcohol is not defined. Do you know why is this error, Elvis?
So alcohol is not defined.
Yeah.
I think df alcohol not defined. Okay, first, I think first of all, there is no inverted commas, right?
Yeah, that is the thing, that when you want to talk with Python, literally, for example, let's say that you want to say to Python, hello. Do you see that it gives me this error, right, Arya?
Yeah. Hello is not defined.
When you want to literally communicate with Python to understand it, you need to use the string object. Okay?
Okay.
The string object is done by placing the quotes here. So if we put hello between the quotes, do you see that it's working, right?
Yeah, now it's working.
So
we'll
how do you...
put it in commas, inverted commas.
Yeah. Try to put it in this cell here.
Yeah.
Click because...
Okay.
There is a trick normally. Yeah, good, perfect. There is a trick in the computers that if you double click in the alcohol, you go.
Yeah.
And then you type the quotes.
Okay, so it will come on both ends.
To both sides, yeah. Like it's a good habit to get these tips so that you work more efficient. Okay, so now we have got the numbers of this column, right?
Yes.
So
now we'll pass it to X.
That's it. You go.
Okay, so I'll write X is equals to df and alcohol.
Would you have gotten to the same conclusion, Elvis?
Because from what I can see, she's passing it to an X object, right?
Yeah.
Okay.
Like we are creating an X object.
Okay.
So that Python, when it comes here, now it will understand what is X.
What is X? I understand now.
Yeah, because if we use X now, you have it there.
Yeah.
You see?
Oh, yeah.
Yeah.
No, it's making sense to me because I understand this concept. So I understand. Yeah.
Good. And now if we execute again, it tells us that y is not defined.
Now
Yeah.
we'll do the same thing for y.
That is it.
The same
Go.
thing, eh? Top.
Okay, so y is equals to df accidents, right?
Mm-hmm.
Another trick, if you use the tab here, it will autocomplete the, sorry,
Okay.
here, the tab key, tabulator.
Tab key. Okay. Yeah, I got it.
Perfect. So now you execute and then you execute again.
Yeah, and then I'll execute it.
Okay, so do we get the same error as before?
No.
This is a
Now we
different
have
one.
huge error.
Every
Yeah.
time that we get an error, we should check, we should understand the error. Like, for example, when you go to a doctor, the doctor first diagnoses the illness, right?
Mm-hmm.
Yeah.
Otherwise, they won't know which treatment will be given to you. Because normally when we program, there is a general tendency that our mindset is trying to solve the problem, is not trying to understand the error first, you know?
Mm-hmm.
Yeah.
So we should be paying attention to the errors in a way
Curiosity.
that we develop a skill to communicate with the computer somehow. Okay? Yes, Elvis, you had a question?
I think curiosity.
Yeah, that is it. And then here, what do you think is giving us this error, Arya? You go all the way down.
Yeah.
Normally the errors are shown at the bottom, the reason why
Here.
you get them.
Yeah.
And
Expected 2D array, but got 1D array instead.
yeah,
So
and they are telling
it
you
wanted.
these numbers, right?
Yeah.
So these numbers to which column correspond?
Alcohol.
Alcohol, right? So do
Yeah.
you see that they are giving you also a tip on how to solve this error?
Yeah. Reshape your data either using array or reshape.
That's it. So based on this error, what do you think you should do?
I should reshape my data.
And would you try to do that with a code?
It is saying reshape -1, 1. Should I type that?
You go with your intuition?
First, I'll use x dot reshape.
Okay.
And
Elvis, would you have do the same?
Okay. It said array.
Yeah. Do you know what is an array?
Array. I understand what an array means, but that means we have to. Is there need of importing NumPy?
Yeah, it has a sense with NumPy. An array is just an object of Python that can store more objects.
More, yeah.
Okay.
Okay.
So do you see area here in X that we have many objects? Like we have this number, and if we put 0, it gives us this number. If we put 1, the second number, etc. Right?
Yeah.
So that's the reason why the X is an array-like object. Okay? And then you tried the reshape here, right?
Yeah.
If I would execute here, why am I getting this error?
Series object has no attribute reshape.
Yeah. And could you have prevented this, Elvis?
Let me see.
Like to know that the series object didn't have the reshape and giving you the control. And try to explain area why.
Okay, series object has no attribute reshape, and yes.
What's your mind thinking right now?
Okay.
To understand this error. The question was, I have this object, the X, could you have prevented this error? Like the series object has no attribute reshape, with the trick of the tabulator, with the dot tabulator, the to completion tool.
Okay.
Because there is this concept area in which after you put the object, if now you access the object with the dot notation, you need to put a dot, Elvis. You see that Python is suggesting you a list of words, right?
Yeah.
These are what you can do with this object, okay? So if you are typing reshape, do you see that the list disappears, right?
It didn't come. There's no reshape. No reshape.
So if it doesn't come, you cannot do anything.
So that's how we have to prevent the errors.
Yeah.
Okay. So that means it's very important for us to understand what we can work with. Okay, I get it.
That's it. And that's why you should be focusing more at the beginning when you are learning programming to know these tricks.
Yeah.
You know, because these tricks are general to anything. If I now use, for example, A, and I use the dot tab, if I put reshape, it's not working neither, right? And now the thing is that we are working with a different object, but the concept is the same, right, Arya?
Yeah.
Good.
You cannot use reshape with that.
That's it.
Operator. Yeah.
So how then can we reshape this object? If we cannot do it. Yes.
Or we could just use reshape and pass X into it. Can we do that? We could write reshape and then use parentheses and put X inside that. Would that work? I don't know.
Okay. So you say here, can you try?
Yeah. Wait a minute. Yeah. Yeah.
Okay. So you think you lack to have something inside the parentheses? Okay. Or this. Okay. This may be a possibility. It may be a possibility. The thing is that the way you are trying to access the function reshape is like if it was a default function of Python, for example, len, that is to calculate the number of elements.
Yeah.
But
so do we need to import a library or something?
That is the thing.
For that?
You would need to maybe convert this object to an array, because do you see here that the error is showing you reshape your data either using an array reshape. So the object, the X, needs to be an array.
So we need to convert the type of X to array.
And now, if you would apply the auto-completion tool, do you think there is a way that you can convert the X to an array? Try to do it. Like the same way we have tried to do the reshape, you need to do a bypass step in which you convert the X to an array. So X dot, and then
array.
You go.
Okay. X dot array.
But try to use the auto-completion tool to validate that you are going well with the tabulator. Okay. Normally, I would suggest that you do this at the beginning all the time, like dot tab, dot tab.
Dot and tab. Okay, I'll try it myself. Dot tab.
Yeah, check. Yeah, type the array.
Yeah. And you can type the array.
Array.
So you can execute
directly
now.
Click. Yeah. Okay, sir.
And you see that it's giving you the output in a different way, right?
Yes.
That's because the type of object is different now. We don't have a series. We have a pandas array. Okay?
Okay, so now we can use reshape.
That's it. And do you see that array is an instance just as the X was an instance?
Yes.
So could you say that you can also access inside this instance with a dot notation? Like this?
Yeah, another instance.
And then
So
now here, you go.
So we can add as many instances as we want.
It depends. If the object contains the instant inside, we can. I mean, for example, if I now want to go to data.
Dot reshape. Okay.
Yeah, you would go to reshape or to whichever thing is reshape. So we type reshape, we see reshape is a function, we put the parentheses, and then we follow the instructions. Good?
Yeah. Yeah.
Okay. So now going back to the problem, if I copy paste this and execute, do you think that we will solve the error?
Yeah, I guess.
I execute, but I get the same error. Because if I go to X now, do you see that we don't have the array yet, right?
No, we don't have
We still have the X. And that's why, and that's because when we convert the array and reshape it, we need to overwrite the X so that the change is applied, you know?
Yeah. Okay.
Do you get the sense? Elvis as well?
Yeah.
Good. So now I execute and has been done okay. We don't get any error already, right? Okay.
Yeah.
So where is then the mathematical equation?
On the Google.
Don't you think it should be calculated here? When we apply the fit function? Because if we go to the documentation.
What exactly is fit function doing?
Fit, it means adjusting, calculating the mathematical equation, the numbers of the mathematical equation.
Okay. Okay.
So here, do you know how to access the numbers of the mathematical equation with intuition?
Access the number?
I mean, you would try to check what we have stored in reg, right?
Yeah, so we'll just write reg.
And execute.
Yeah.
But do you see that we don't have anything? We just have linear regression, right?
Nothing in the parentheses, yeah.
So this is another concept of programming. What is reg?
An instance.
Do you know what is an instance, Elvis?
I've never, this is the first time I'm hearing instance.
Instance is similar to object, is a data structure.
Oh, okay. It's okay. I know object.
Which is different from a function, okay? Yeah. So if we want to ask Python the attributes of this instance, we do this all the time, dict. Okay, this is a universal access to get the attributes of an object. So if we execute, we see some numbers here, right?
Yes.
And which is the mathematical equation? The mathematical equation here would be accidents equal to the intercept. So we copy paste plus
coefficient.
Coefficient, exactly.
And features.
Or and X. Then the feature that is alcohol. Okay?
Yeah.
Do you get it, Elvis?
Yeah.
That is it. So now, how could we calculate the predictions? Remember before, Aria, that I told you every time you want to do something in programming, what do you need?
Yeah.
An instance,
You
a
have
library, a function.
a function.
That's it. So you now should be thinking on the function to make the prediction, right?
Yes.
Like the function that you substitute an alcohol here, and it gives you the result for the accidents, right?
Yeah.
Okay. So I'm asking you, in which object do you have the mathematical equation, the numbers? In which instance?
In instance, alcohol.
So if I put here alcohol, it's not defined. There is something that we have created that contains the number of the
X,
function.
X, I think.
Okay, if we put the X, this is the numbers of the alcohol, but it is not the numbers of the equation.
So we'll have to define a equation first or write a function equation first.
Reg. This is the object that computes the numbers of the mathematical equation with this function. Okay?
Okay.
So do you see how we previously accessed the reshape function?
Yes.
From the X?
Dot
We
reshape.
do the
Yeah.
same, but we access the functions of the reg instance. You go.
Okay. So I'll write
Because the thinking goes like this. If
reg.
you had a function to calculate the mathematical equation of the model, which was fit, we should have a function to calculate the predictions of the mathematical equation, right?
Yeah.
Yes.
So if you go down, which one of the function is it?
To predict.
You go. And now if you want to ask Python how to use this function, shift tab.
Shift tab. Okay.
Yeah. That is it. And now the documentation is telling you what you should pass to Python
Okay.
to this
Okay.
function.
Array like parameters. So X, we could use our X,
Yeah,
which is an
that's
array.
it. Do you get the sense as well, Elvis?
Yeah.
These tricks of the shift tab, tabulator.
Yeah.
Are you implementing when you are using the
Yeah.
Python?
Yeah. Yes, definitely. When I want to call a function, same thing. I use the shift enter, shift tab.
Perfect.
Okay.
Okay, so now we've gotten these predictions, right?
Okay.
We have here df, right?
Yes.
How can we add a column that puts the predictions?
Df. That we have to add a column for prediction.
The thinking goes like this. If I access a column like this, I can put here a new column name, red, and then
Okay. And then merge it into that one.
that's it. I copy paste this, and then when I access df, it gives me the prediction here. Did you know this, Elvis?
I don't know. The way I merge into a column is okay. Maybe I'll show you my code. How I merge the column. This is a shortcut, anyways.
Do you know how? Elvis?
Huh?
Like, do you normally create a new column like this?
I've created twice, but I've not merged like this. Okay, df predict then equals reg.predict x.
Yeah, it's
okay,
like
I understand.
this function returns me this array.
Yeah.
So if I want to put this array inside
I understand, yeah.
the data frame, I just put this. Like in the end, what matters is not this, but the object that returns this, you know? Okay, so now, how can we visualize the predictions with the real data? Let's check the graph we did before here. And let's go to copy paste it. So here, could you apply some intuition area to now place the predictions in the graph? So the thinking goes like this. If here you get these blue points by putting data df, y accidents, and x alcohol, what you should do now is to put predictions in the second one.
Yeah.
You see?
Yes.
Okay. Do you think you could use a line as well instead of a scatter plot? A scatter plot means that you are making a dots graph.
Yeah. Yeah. So how do I make a line?
Yeah, and applying the auto-completion tool.
Okay. Here?
Yeah. So you would delete this, right?
Yes.
And then access, and then there should be a function that produces you a line. So if you start typing the line L.
Okay.
You get
line plot.
You go. And then execute. Do you see why it's doing this line?
Yeah, because I used accident.
That's it. So we should use the prediction.
Yeah. Great. And
there we are.
Yeah, we could erase this line, second line.
Yeah. Would you know how to change the color of the blue line by intuition?
We'll add another parameter called color to it.
That's it. Would you know how to do this, Elvis, from the previous YouTube?
Yeah, that's the way we did, we went to YouTube, checked, then we actually imputed to check what we can do with this.
Yeah.
Yeah.
I'm gonna check. So how do you think is the parameter called to
color?
You try. Try with the color, because sometimes this doesn't work, like the auto-completion. Like 80% of the time, when you put here the tabulator, it just shows you the CI parameter. But the thing is, when you go to the documentation and you see here a hash key, and also here, this means that you have got more parameters that are general and you could use it. So color is one of them.
Okay.
Because we don't have the color here, right?
Yeah.
But nevertheless, if we use the color, it will recognize it. You go, Aria.
Equals green.
So I'll pass a color or something.
Yeah, you go, like red, for example.
Yeah, okay. So I'll use red.
Execute.
Is it? Yeah.
There you go. Like when you are learning by yourself, try to do these things, and to even reinforce the knowledge, try to put some other color, you know?
Do we have a like specific list that we have to choose from this only?
Sorry?
Like I can use magenta also. Is it valid color?
I don't understand, sorry.
Suppose I have to take the color as magenta. Is it a valid color that
Try
Python is
to
taking?
do it. You try. Magenta?
Yeah.
Yeah.
Yeah, it is
It works.
showing.
Okay.
Yeah.
It works. Okay.
And maybe if you would like to go in Google and to check which possible color you have, you go with, okay, what am I using here? SCNS. So what is SCNS? Seaborn. Okay, an align plot. Okay, so Seaborn. Oops. I get these errors quite often. That's everything in my computer shut down. Now it's good. Oops. We were here. Okay. So Magenta, we go in Google and then here we can search Seaborn color option.
Correct.
Then we go here where it tells us something, but this is another, this is like a palette. This is a sequence of colors, but not color palette, color guide to Seaborn palettes. Yeah, it's all the time colors. Color names. But yeah, they are still okay. I think here in Stack Overflow, there we have it. This is also a skill like everyone should strive to acquire. At the first sight, we try to search in Google color options, but do you see that Google is even predicting us some of the questions?
Yeah.
The moment we do it and we check another tutorials, in the end we get to have the solutions, you know. So you need to be quick enough to detect when a tutorial isn't worth your time, so that you go to Google and check for another, because there is the solution all the time. Okay, so coming back here, how good is the model? Because the model is obviously not perfect, right? For example, if you take maybe this point in the line from this real point in the graph, do you see that we have an error, right?
Yeah.
Yes.
So how do we calculate this error? The thinking goes like this. If there was a function to calculate the mathematical equation, if there was a function to calculate the prediction, it should be a function to calculate how good is the model, right?
Yeah.
How would you search for that function, Arya? Remember the object we were working with in the model?
Yeah, reg.
Reg. So in the same thinking, applying intuition, you may you may search for the function that gives you how good is your model. So here you have just two functions, fit and get params. Then you have predict, you have score, and you have set params. Which of these functions seems to you that it gives you the how good is your model?
I think either predict or score.
Predict, we used it before. That was to get the prediction.
Yeah.
And if we want to get, yeah, we can try with a score. And then how do you use it in the score?
Score of X.
But you should ask Python how to use the function. Shift tabulator.
Yeah.
Yeah, in the end, like try to get the habit of asking first the documentation of the function. And at some point you will see that it's all the time the same thing. So you wouldn't need even to look at the documentation.
Okay, so shift tab.
And then what is it asking for?
To return a coefficient of determination of prediction. Here it gave like x comma y.
Yeah.
So we could use x comma y.
Yeah, that is it.
Okay, so x comma y. Yeah, it is. But what score does it mean?
So what is the meaning of this? It means that we can explain 72% of the variability of the accidents. You know?
Okay.
Please say
Yeah.
that again.
So
Say that again.
Sorry, Elvis?
Please, can you say that you said something? Can you repeat that again?
Ah,
What does call mean?
what do you mean?
You
Sorry.
said I didn't get what you said. Like, what does this call mean?
Score is the function that we use to calculate how good is the model.
How good is the model? Okay.
Yeah, and this gives us a 0.72. This means like our model is explaining 72% of the variability of the accidents. That is the variable that we want to predict.
Okay, is it the accuracy level?
It's related. The thing is that the accuracy is applied when you want to classify categories, but not to calculate numbers.
Okay. So yeah, got it.
So like how this number has been calculated, we can have this thinking process. For example, you have accidents and then you want to see the difference with the prediction and you get the errors. Okay, so the F errors equals to this. Then you want to sum the errors, but if you sum the errors, you get 0, right? Because that was what we explained in the video before. And if we want to make the sum and to not to have 0, we need to square the error. And then here we can create a column for the squares error. And there we have it. So now we don't have anymore the negative values. So when we do errors to the square and we sum it, we get this number. This number is called residual sum of squares. Residual because errors, right? But we can think, okay, 231 apples or what? Thing is, this model was to predict the accidents, right? So we have a lot of numbers here in the accidents. We need to check how in reality the accidents varied. How was the error? So we subtract the mean. And because of the same reasoning, we square and we apply the sum. And this is called the total sum of a square, TSS. And then we think, okay, if RSS is the error of the model and TSS is the total amount of error the model should have, if we make a proportion, this is the percentage that the model is failing, right?
yes.
So if we subtract that from 1, we get the same number than when we apply the score.
Yeah, so score is equals to 1 minus RSS by TSS.
Yeah. Probably I will upload videos to make the explanation clearer on these matters. Okay, so do you see how everything went? Like in the end was all about to calculate a mathematical equation, but that shouldn't be enough. We also need to check how good is the mathematical equation, right?
Yeah.
So now, Elvis, we can we use more models to make these predictions? What do you think?
Okay, yes, we could, I guess.
Because of the tone of them, my question, no?
Because we already use the linear regression, so
yeah, like we have many models to calculate predictions. One of them is the random forest, you know?
Okay, random forest, okay.
So if you wouldn't know a random forest, you would go to Google and you would say, okay, random forest, Python. You look in the some tutorial, and then you look for the code. Here you see the parentheses, but there is nothing related to random forest. So you keep it going. Here the same, nothing related to random forest. Here the same, nothing related to random forest. And the same here. Then here we don't see the random forest yet. So you keep going down. We don't have it yet. And then here we have it. Yeah. So we copy this and we paste it on the computer. Now, what do we need to change here? Because if we execute, we will probably get an error, right? Where do we get the error?
Train feature not defined. Train feature.
So we
X
apply.
and Y.
Yeah, X
That's
and
it.
Y.
And we shouldn't even need to know this. I mean, we can go to the function, ask the documentation, and it tells us what instance should we put here. X, Y, so the same we applied before, X and Y.
Yeah.
And then everything was executed. So by the same logic, we can apply the predictions with this new object, predict, and then X. And then we get another predictions. So pred random forest.
In a column.
And then you see that these predictions are a bit better than the predictions of the linear regression, right? For example, for this state, Alabama, we have got a prediction of 17 in the linear regression and 18 for the random forest. And it's better to the real data, right?
Mm.
So if we would like now to do the same thing with another model, support vector machine. So we go to Google, support vector machine. Because when you do assignments in online courses or in the university, the teacher will always ask you, apply this model or apply this other model. Or maybe you can think here, apply curiosity. And then, is there any other model rather than random forest, linear regression, or support vector machine that I can apply to my data? So you try that out and you check the possible errors and you understand why is it giving you an error, why isn't it giving you an error, etc. You know, and then you get some fundamental knowledge about Python and machine learning in a better way, I think. So here, super vector machine, Python. I go to some tutorial. I look for the code. Here they are using, we can try to check another codes. Classification. Okay. Here is the same. So we may copy paste. And then we can even execute if we delete this X and Y. So we do the same prediction of the support vector machine equal to SV rec dots predict and the X. And then now we get these other predictions.
It's better than, yeah.
You see that we have got 3 models. Now, if we want to put all of them into a graph, we would do the same thing as before. So, for example, if I want to add the random forest, I would use predictions of random forest. And do you see that the predictions are way better? Like they are
way better.
the point.
Yeah.
So if we use the normal prediction of the linear regression, we see that the model of the linear regression is not as good as the random forest. And then the other one was the support vector machine. is not as well neither than the random forest. We can put some labels to check. I'm gonna copy paste, and this is it. So how good is every model? So we have the linear regression. We apply the score. We have the random forest. We apply the score.
Yeah.
And then we had the support vector machine. We apply the score as well, X and Y. And which model is the best, Elvis?
Random forest.
Random forest, yeah.
Because it tells you like 95% of the data is explained by this model. And you can see that also in this.
Okay. So a question, please. So are we to check different models to know which, like, to get which one is better to get?
Yeah, you do all the time the score. For example, here I have a blog in which I explain like machine learning is all the time the same thing.
Okay.
Fit, predict, score, repeat. Fit, predict, score, repeat. For example, here I do a decision tree. The only thing that changes is the object here. Fit, predict, score. Then I do support vector machine, and it's the same. Fit, predict, score. The only thing that changes is this.
Okay.
And in this other model is the same thing. Fit, predict, score. That's why I say that you don't need to understand the maths behind the models, because knowing that all you need to do is the best possible model, you compute the accuracy, and then you just pick up that model, you know?
Okay.
That's the mystery. Like
this is the mystery, huh? This is your blog, yeah? Okay, check it out.
Yeah. So do you have any doubt as well, Arya?
No, it is clear till here. And does it vary depending upon the problem, that here random forest is working the best, and in some another problem we could have support vector machine doing better job than
it depends on the data that you have. In some data you can apply better the support vector machine or the linear regression, and also there is the decision tree, but there are many models. Like if you go to scikit-learn library, here they are telling you which types of model you have. So you have classification when you want to classify categories. You have regression when you want to predict a number. And if you click here, you will see all of the possible models. So for example, you get to regression here, and then you see decision tree regressor, fit, predict. It's all the time the same thing, all the time. Yeah. Also in the Twitter, you can ask me for any model that you want or whatever. Like
yeah,
it will
sure.
probably be a list to it. But like normally you like, let's say that you are working for a bank to make a model whether to give a loan to a client or not. You would use like 3 or 4 models, and from all of them you would use the one that gives you a higher accuracy.
Okay.
And like you don't really need to know the mathematical process behind every model, as long as you know that you will pick up the best model.
Okay.
Based on the accuracy.
Based on accuracy, okay.
Yeah. So it's all the time the same thing. The thing that changes is the visualization of the model if you want to do different models. Because, for example, if you want to plot a random forest, if you get into the random forest object, you see here that we have got a lot of trees. You know, they are like 100 trees. So do you think we are going, well, they are 1,000 trees. Do you think that we are going to plot 1,000 trees? No, right?
No.
So there are some times in which we just get the accuracy or the score. We just say that this is the best model. And there is a thing called feature importance to tell you which explanatory variable had more influence. For example, for me, when I get researchers that they are working in medicine, they want to pay attention to which factors are the ones that influence the most the outcome variable. For example, the regression to have a cancer, or for example, which factors influence to have this illness or this other illness.
Okay.
That's like another topic. Like this topic would be, for example, where we calculated the linear regression and the mathematical equation. We would say, what is the influence of alcohol on the accidents? We would say, for every unit that we increase in the alcohol, the accidents will increase in 2.03 units. So that's how you can figure out which factors influence the most to have a cancer or not, to apply some treatment or pay attention to this other factor.
Yeah.
There is a whole topic about it. But yeah. So good. How was everything?
Fine. It's you. Please, could you share your blog on Twitter?
Yeah.
Please do. I'd love to see it.
I will
share it as a tweet or a message.
Yeah.
Yeah, like if, for example, to have access to all my content, I have put a pinned tweet here. So if you click on this link, it will give you the kind of my story, and here it's the YouTube.
Okay. Yes.
So I will probably need to organize this better. Like I need some time, but
so that everything can be in the same place.
Yeah, I need to organize this. The thing is that, for example, tomorrow I'm going to a company to teach Python and Amazon Web Service, and I'm gonna be full 5 weeks in this training. So
the companies we post our CV to, they tell you to learn Python before you come to the company. But
sorry,
yeah, did you hear me?
Yeah, can you repeat?
I said the companies we apply for, they tell us to learn Python and know all manner of stuff for entry level, 6 years experience, 3 years experience for entry level.
Yeah, but I mean, they ask you so much experience and knowledge that I don't think any of the candidates have everything, So it's a pity that most I don't know, people don't apply to jobs because they think they need to fulfill all of the requirements, but you don't know that. I mean, the company may be interested in your profile because of another thing, even you don't know 50% of the things they are demanding for. Just apply, and then they will tell you maybe if you need to do something else.
Okay.
If you don't apply, you'll never know.
Yeah, true.
Yeah.
True.
So good. Maybe for next day we can do a decision tree.
Okay.
Probably.
Yeah.
So you need to prepare for your space, man.
Yeah.
Yeah.
Yeah, you should have a proper schedule for it.
Sorry?
You should have a proper schedule for it. Can you hear me?
Yeah. I should have a proper
schedule for Twitter Spaces.
Yeah. Don't worry about that. Like having like 15 minutes, I think is enough.
Is enough, yeah?
Don't worry. So for next time, I'm preparing this GitHub repository where I am uploading the code. So if you go to YouTube tutorials, here you can check the code for today. Like I will later upload the solution.
Okay.
Okay, I'll download it.
Oh, yeah. Sure.
Like to be honest, try to, for example, use another data set or
there's a California or the Boston data set.
That's it. Like, for example, you would go here, you duplicates the file. And then here you start working, instead of car crashes, you can do, for example, total tips. The thing is now that we won't have these columns. And then you would try to do a linear regression, random forest for this data. And then you will get errors, you make the doubts, be curious, and then maybe we can solve it next time, for sure.
Okay.
Yeah.
Good.
I'm very much looking forward to next session.
Sure. Like I need
I
to
liked
organize
it a lot.
because
Yeah.
maybe next weekend I'm gonna be in another city, but I'm
Which city?
gonna try to organize myself to tell you like 5 days in advance before, and I'm gonna try to do this weekly. So probably around Monday, around Wednesday or so, I will tell you the date for the next one.
Okay,
Yeah.
surely.
Please continue holding your spaces because you are really motivating many of us. Because right
Yes.
now, yeah, you're really doing, because many I think I contacted over 3 data tech guys. They didn't respond to my DM, so I think only few. So you are the first person that, okay, I think
You got lucky, yeah.
Yeah, I can't remember.
Honestly, I also got lucky because I mean, like to me, for example, replying to you was like a train that passes, and if you take it, it will help you, because you interacting with me and everyone is helping me a lot to know what can I do, what I can try, and to do these things. And I think this can help me as well to get more clients in the future. So like,
true. Because many people are confused in machine learning and data science. They don't really know a clear path.
Yeah.
On how to
And to be honest, like I like to do things well in a way that's not just chatting in Twitter and saying you should do this, you should do this other thing. Like I like to be practical and help you in the best possible way that I can. So that's why I'm doing these YouTube sessions, etc. Like I thought about these things earlier ago. The thing was that I was putting tweets and trying new things, but I didn't see people were as much interested like you are, for example, and that's why I didn't started this thing earlier. But it just takes time. Like
it takes time. Yeah, true.
To wherever I'm gonna be, I will be. So just sooner or later.
Yeah, definitely. Fine. Definitely, man.
Yeah, definitely.
Okay, please go prepare for your space, man.
Okay, so thanks a lot.
Is it scheduled for now?
Sorry?
Or is it scheduled for now?
20 minutes.
Okay, I'll join it.
Yeah.
Okay, ciao.
Okay, people. Thanks a lot for coming. Really a pleasure.
Yeah, thanks a lot for teaching. Yeah.
Pleasure.
Bye-bye.
Have a good one. Ciao, ciao.
Yeah.